And finally, for the last section of this lab, we have the reduction-oxidation reactions. And that was where we had this section of 3 metals and 4 ions, right, that we reacted together, and you should have seen that it reacted in something like this way. Okay, so what we have when we're putting in these equations, it gives us this much: the copper metal plus silver ion to produce silver metal plus copper 2 ion. All right. So when we do this, it's pretty straightforward, I think. The copper metal, right? Anytime we're talking about the metal that is, it'll have a 0 charge, okay, and that's the solid copper, right? And then the silver ion, okay, that's where we're talking about the charged particle, and therefore it is aqueous, because that was the solution that we added to the actual metals. All right, and then we produced silver metal, so now the silver is the one that has a 0 charge. You would actually put that 0 in on Chem 21. Silver metal, which is a solid. That was the black substance, or the grayish substance that formed on the copper wire. And then here we have, and it's telling us the charge, copper 2 ion. Okay, so it's pretty basic there, and then of course the ion is aqueous. Right? Now there's just one thing that we have to take into account, and it mentions this as well. It has a note that says, to balance redox reactions, you must make the total charge on the reactant side equal to the total charge on the product side. All right, so that means not only do we look at this and say, well, I have 1 copper atom and 1 silver atom, so it should be balanced, right? No, because I also have to make the charge balance, and here I only have 1 positive charge, here I have 2 positive charges, so I have to put a 2 in front of that silver, which means I need 2 silver atoms over here as well. All right, so just one little detail to take into account there. I'll do one more example. There's 6 of these total, but we have the magnesium metal, right? Again, all the metals will have 0 charge, and they will be in their solid form, right? We're talking about that little magnesium ribbon that we used. And then the hydrogen ion, that's this one, so we're talking about this reaction here. The hydrogen ion is just the H+. And since it's the ion, that one's going to be aqueous. Right? Then that produces hydrogen gas. Remember, hydrogen gas is H2, and of course that's a gas, so that'll be G. And of course, all of these ones that are neutral, they will have a 0. We don't write them, but you would put that in on Chem 21 as a 0 there, because it has no charge, it's neutral. And then we have the magnesium ion, and magnesium ion has what charge? A positive 2 charge from the periodic table, because it's in that second column. It's an ion, so this is aqueous. Right? So once again, we balance not only the atoms, but we balance the charge, and so we put a 2 in front of here, and that satisfies both the 2 atoms of hydrogen and the positive 2 charge. Okay? Now the last problem asks for an order of reaction. Okay, it calls it the activity order. Basically, it's saying which one of these, we have 7 different things, and it calls them all metals because the hydrogen ion, even though it's not technically a metal, it behaves in some ways as a metal. But anyway, out of these 7, which one is the most reactive? And rank them from most reactive to least reactive. So it's kind of a unique question, but here's how we approach this problem. Right? First of all, let's realize that only 3 of these are actually metals. These are all ions. Okay, so at first glance you might say, well, clearly silver is the most reactive and calcium is the least reactive. But in fact, what we're asking, what the question is asking, is it's wanting to compare the 3, let's just put these all out here. Here are the 3 metals, right? And it wants all 7 of them in their metal form, okay? So aluminum metal, not the aluminum ion, calcium metal, not the calcium ion, silver metal, not the silver ion, and the hydrogen as an element. We're looking at these. Okay, so we're just going to write H in our block, not H2. All right. So now the question is, what is the rank here? All right. So what we're going to do is look at this. Now I was saying that it looks like the silver ion, or the silver would be the most reactive, but it's actually the silver ion, okay, that is reactive. So the calcium, see what when the copper metal reacted, it formed copper ion. Okay, when the silver ion reacted, it formed silver metal. So that says that the copper metal is actually more reactive than the silver metal, right? Because the copper metal reacted to form the silver metal and put the copper. So in the ion state, that's when it is reacted. Right? So here what we're seeing is the calcium, nothing reacted with the calcium ions, right? Which means that all 3 of these would react with the calcium metal. The calcium metal then, in a sense, like if I had a reaction between calcium metal and, I took the solid calcium metal and I reacted that with copper ions, okay, this would produce the copper metal and the calcium ions. Okay, that's what this no reaction is telling me. Is saying that when I put the calcium ions with the copper, it didn't go the back way, right? That means it would go the forward way, right? So that says that the calcium metal is more reactive than the copper, because the calcium metal reacts with the ions to form the copper and react. So the calcium will react, not the copper react. Okay. So what we can do is just rank these. We look at how many are reacted, and so there's 3 no reactions with the calcium ions. So what that means is, if we look at that in the opposite direction, 3 out of 3, okay, 3 out of 3 of the calcium reactions with the calcium metal, 3 out of 3 would react, okay, or 3 out of 3 didn't react with the calcium ion. So we're looking at it in the reverse for the ions, and then it'll be in the forward direction for the metals, right? So with the silver, right, it's actually showing that with the silver metal, it didn't react. The silver metal didn't react because it didn't go backward, it went forward. It was the copper metal that reacted. So actually 0 out of 3 reacted for the silver metal. All right. For the hydrogen, 1 out of 3 reacted. So we can just do this little ranking, and it will. And then here, the aluminum, 2 out of 3 for the aluminum metal would react. Okay. Now for the other 3, we can look at it directly and say, all right, the copper metal, 1 reacted out of 4. Okay, so for copper it's 1 out of 4. For magnesium, 3 out of 4. Okay, so the magnesium is more reactive than the copper, and then the zinc, 2 out of 4 reacted. Okay, so we look at it like this, and now we have our rank, and we're ranking these from the most reactive to the least reactive. All right, so here, let me just put this in decimal form for each of this. This is 0.25, 3 out of 4 is 0.75, 2 out of 4 is 0.5, 2 out of 3 is 0.67, 3 out of 3 of course is 1, 0 out of 3 is 0, 1 out of 3 is 0.33. Right? So we're just ranking them from highest to lowest. We have the calcium is the highest, then the magnesium, then the aluminum, then the zinc, then the hydrogen, then the copper, and finally the silver is the least reactive. So this is the answer, and that's how you come up with it, by ranking them according. But the main thing with this, you just have to realize that the ions, this is already their reacted state. So we're talking about the metals, and so you have to reverse those ones. All right? Hopefully that clarifies where you get that and saves some points. Okay?